Okay, this lesson is for Mrs. Cucci's College Now Pre-Calculus class. This is lesson 3.5 continued, and we left off on page 1.16, I believe, where it says horizontal asymptote. So if you're not already on this page, please get to it. Okay, so what we're going to talk about today is how we find horizontal asymptotes. So we're going to first take a peek at this graph. Okay, so 1 over x minus 3 is the graph that we're looking at. Okay, so here's our graph. So essentially what we're looking for is horizontally, are there values of y that are not getting used? And what we wind up doing is we wind up just taking a peek at this graph and seeing that as we extend out, this graph seems to be getting closer and closer and closer to equaling 0, y equaling 0, but it doesn't actually seem to ever get there. Okay, and another way for us to look at that would be to take a peek at that table and see that the y value, although getting very, very close, never actually reaches 0. Okay, the higher x gets, or the lower x gets in this case, the closer it gets to 0, but never actually reaching it. And same thing in reference to as x gets getting larger, the y value also seems to be approaching 0, but never actually gets to it. Okay, so that's another way we can look at it. So another way to say that is it seems to be that as 1 over x minus 3 approaches 0, x seems to be approaching infinity, right? That value of x just keeps getting bigger and bigger, and it seems to be approaching 0. And same thing on the other end. As 1 over x minus 3 approaches 0, x seems to be approaching negative infinity. Okay, so it seems to be getting closer and closer to 0 without actually ever getting to it. So what we can say is that that's a horizontal asymptote. We can say that at y equals 0, we have a horizontal asymptote. So this one was actually pretty simple to see graphically. Okay. So we see that a function approaches the x-axis in both instances. This tells us we have a horizontal asymptote. So we're going to look at finding the horizontal asymptote for negative 7x to the 4th minus 10x squared plus 1 divided by 11x to the 4th plus x minus 2. And here's how we're going to go about doing this. Okay, so the first thing we're going to look at for horizontal asymptotes is we're going to look at the degree of the polynomial. So we're going to take a peek at the degree. Okay, the degree in the numerator is 4. The degree in the denominator is also 4. Okay, and this is going to be really important. The rule is if the degrees in the numerator and the denominator are the same, what we can do is we can take the leading coefficients, and that becomes our vertical asymptote, or horizontal asymptote, I'm sorry. So since the degrees are the same, what I can do is just take this. Okay, and we can say that there is a horizontal asymptote at negative 7/11. So that's a really easy rule for you to remember. Okay, so same degree. Okay. Take the ratio of the leading coefficients. Okay, so the next one is finding the horizontal asymptote for 2x plus 3 over x cubed minus 2x squared plus 4. Okay, so we're gonna look at the same general thing. First, we're gonna look at the degree. Okay, the degree in the numerator is 1. The degree in the denominator is 3. Okay, since the degree in the numerator is less than the degree in the denominator, we can say that the horizontal asymptote is 0. Y equals 0. Okay, so this is another one of those rules. If the degree in the numerator is less than the degree in the denominator, you automatically have a horizontal asymptote at y equals 0, or along that x-axis. Okay, so that's another rule. So if the degrees are the same, you take the ratio of the leading coefficients. If the degree in the numerator is less than the degree in the denominator, you have the horizontal asymptote of y equals 0. So it's not a bad idea, if you haven't already, to make a note card with these, okay? And then likewise, if the degree in the numerator is larger than the degree in the denominator, you don't have a horizontal asymptote, okay? So if the numerator is greater than the denominator, no horizontal. Okay. Okay. So determining horizontal asymptotes, again, these are your rules. I have them written down for you, but again, you should make a flashcard. When the numerator and the denominator of a rational function have the same degree, the line y equals a over b is the horizontal asymptote. So again, you're taking the ratio of those leading coefficients. When the degree of the numerator is less than the degree in the denominator, you have a horizontal asymptote at the y-axis, or x-axis, or y equals 0. And when the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay, so now we're gonna do some practice with graphing. So we've got 2x squared plus 1 over x squared. And so we should start thinking about automatically what kind of things we have here. Do we have a vertical asymptote? Do we have a horizontal asymptote? So we're going to take a minute to actually go through this and graph it out by hand. Okay, so let's think about any vertical asymptotes to start. Okay, any vertical. Now remember, vertical is where the function is going to become undefined. So we need to look at our denominator for our vertical. Okay, when does x squared equal 0? When we know x squared equals 0 at x equals 0. Okay, so here's our vertical asymptote at x equals 0, which of course we know is that y-axis. To look for the horizontal, we want to look at the degree in the numerator and the degree in the denominator. And since the degrees are the same, we can say that it's the ratio of the leading coefficients. So we have a horizontal asymptote at 2 over 1, which is the same thing as 2. Okay, so right there we've gained a lot of important information. So what we're going to want to do is we're going to want to take that information and put it onto a graph. Okay. All right, so asymptotes, that's where we're going to start, right? We're saying that we have a vertical asymptote at x equals 0 and a horizontal at y equals 2. So x equals 0 is right on this y-axis. We're going to put dotted, right? Always dotted for asymptotes. And then our horizontal is at 2. So 1, 2. So we know the functions are never going to touch those green dotted lines. So the next thing we're going to do is we're going to come up with a table for this. Okay? So we want to know maybe, we'll say -2, -1.5, -1, -0.5, 0.5. We know we don't need 0 because it's undefined there. 1, 1.5, and 2. Now the easiest way to do this would be to go through and just pull up a table on your calculator. For the sake of time, I'm just going to put those values in. And again, like I said, you could put these into your calculator and figure out what those values are. And now we're going to go ahead and graph. So at -2, I have the value of 2.25. So -2, 2.25. Maybe right here. It's above that asymptote. -1.5. It's a little bit higher. Okay. -1. It's at 3. -0.5. It's at 6. So now it's spiking up, right? And what winds up happening is it follows along these asymptotes and it gets arbitrarily close, but it never actually touches them. It just kind of rides along them and getting closer and closer and closer without ever really touching. On the other side, we have 0.56. We have 1.3. We have 1.5 and 2. Okay, so same thing is happening here. It's going up and getting arbitrarily close, but never actually touching. And same thing along this axis here. Okay, so here is our function of g of x. Okay, so that's how we graph using our asymptotes. All right, so we're going to stop here. And tomorrow's lesson will be on oblique asymptotes or slant asymptotes. Same kind of idea, except we're going to be using long division to determine slant asymptotes. Okay, thanks guys.